Good morning Year 6 and welcome to our next home learning lesson. Today's learning objective is to understand that the angles of a triangle add up to 180 degrees and the angles of a quadrilateral add up to 360 degrees and use these facts to calculate missing angles. So let's look at what a triangle is. A triangle is a three-sided shape. It's a 2D shape. All its sides are straight and has three interior angles that add up to 180 degrees. That final fact is one that you will need to really remember today, as that will come in very handy. So we're going to look at different types of triangles. Firstly, we have the equilateral triangle. Do you think you know any properties of an equilateral triangle? What do you think equilateral means? Equilateral has the word equal in, so that gives us a little hint. So we know that an equilateral triangle has three equal sides and all the interior angles are the same or equal. If the angle in a triangle must add up to 180 degrees, what must the interior angles of an equilateral triangle be? That's right, it's 60, because 180 divided into three equal pieces is 60. Next we have an isosceles triangle. Do you think you know any properties of an isosceles triangle? Now they have two equal sides. They have two interior angles that are the same, and these are called the base angles, the base being the bottom. Next we have a scalene triangle. Do you know any properties of a scalene triangle? Now all the sides of a scalene triangle are different lengths, and all of the interior angles are different, but they still add up to 180 degrees. Next we have a right angle triangle. Do you think you know any properties of a right angle triangle? Firstly, the name gives one of them away. One of the angles is a right angle, and we know that is 90 degrees. The other two angles will add up to 90, as 90 and 90 make 180, and we know that the interior angles of a triangle must equal 180. The longest side of a right angle triangle is called the hypotenuse. Let's see if we can find the missing angle for this triangle. The angles in any triangle must add up to 180 degrees. How can we find the angle of C in this triangle? What do we know that can help us? Now, we know that this is an isosceles triangle, so that means A and B are the same. So that means B is 70. We can now add 70 and 70 together, making 140. Now we can find the difference between 140 and 180, and that will give us 40 degrees. So C is 40 degrees, and this is an acute angle, less than 90. Let's see if we can find out the missing angle for this triangle. So how can we find the angle of B in this triangle? Again, we're going to use what we know about triangles. So we know that this is a right-angled triangle. We know that it has one angle that's 90 degrees and one angle that is 55 degrees. If we add those up, we get 145 degrees. So that's the information we already have. We can then use the information that we know about triangles, and we know that all the interior angles must equal 180. So if we find the difference between 180 and 145, we'll find that the missing angle B is 35 degrees, which is again another acute angle. Time for a quick task. I would like you to calculate the angles of these two triangles. Number 1, I'd like you to calculate the angles of A, B and C and tell me what type of triangle this is. And then for triangle 2, I'd like you to calculate the angle of C and tell me what type of triangle this is. Remember to use the facts that you already have about triangles to help you answer these questions. Pause the video now and give it a go. So let's look at question number 1. Question number 1, the triangle is an equilateral triangle, and we know that these have equal sides and equal angles, each equaling 60 degrees. And triangle number 2 we know is a right angle triangle, so we can add the right angle, which is 90, to 54, giving us 144 degrees, and then finding the difference between 180 and 144, giving us the angle of 36 degrees. Let's see if you can do it again. I want you to calculate the missing angles and tell me what type of triangles these are. But remember, use the knowledge you already have about triangles to help you answer these. Triangle 3 is an isosceles triangle, so we know the base angles are the same, so A and B must be the same. So to find out A and B, we need to subtract 48 from 180, giving us 132, and then we can divide this in 2 to give us our 2 remaining angles. Triangle number 4 is a right-angled isosceles triangle. So again, we can subtract the right angle from 180, and we can then divide the 2 remaining angles by 2, giving us 45 for each. One final question. Can you calculate the missing angle here? This one's simple. This is just a scalene triangle, giving us 2 angles. We can add those angles together and then subtract that from 180 to give us our final angle of 138 degrees. Now this angle is an obtuse angle as it is more than 90. So last week we started to look at quadrilaterals, and we know that the interior angles of a quadrilateral have to equal 360 degrees. Now this is a square that has 4 equal parallel sides and 4 right angles, 4 parallel sides and 4 right angles. That equals 360 degrees. We then have a rectangle that has 2 pairs of parallel sides and 4 right angles. Remember, 2 pairs of equal parallel sides and 4 right angles, with the angles equaling again 360 degrees. We can also have a parallelogram. This has 2 pairs of equal parallel sides and diagonally opposite angles that are equal. So if we have one angle that is 30 and one angle that is 150, what are the missing angles A and B? That's right, because they're opposite, the opposite to A is 30, so that's 30 degrees, and the opposite to B is 150 degrees, so that is 150 degrees as well. We can check this by adding them all up and seeing if they equal 360 degrees. Next we have a trapezium, and this has one pair of parallel sides. This is an isosceles trapezium. It has one pair of parallel sides and one pair of equal sides. The angles on either side of the parallel sides are equal. So it has one pair of parallel sides, one pair of equal sides, and the angles either side of the parallel sides are equal. So if one of the top angles is 110 degrees, that must mean A is also 110 degrees. And that works out the same for the bottom. If the bottom is 70 degrees, that must mean the other bottom corner is also 70 degrees. We can check this by adding them up again and making sure they equal 360 degrees. This is a rhombus. All four sides are equal and diagonally opposite angles are equal. So if the top angle in the rhombus is 110 degrees, that must mean the bottom angle is the same. And that's the same for the left and right angles. If one is 70, the other must be 70. And remember, all the interior angles of a quadrilateral must equal 360 degrees, so we can check if that's correct by adding them all up. And finally we have a kite. This has two pairs of equal sides and the horizontally opposite angles are equal. So we can work out the missing angle of A by understanding that the angle opposite the 100 degrees, which is B, must also be 100 degrees. So 100 add 100 add 95 is 295. Subtract this from 360 degrees will give us the answer for A, which is 65 degrees. So the most important thing to remember for all of these quadrilaterals is that the interior angle in all quadrilaterals must total 360 degrees. And we can use that information to find out the missing angles of any quadrilateral. Time for today's main task. Complete the worksheet on the Year 6 Home Learning page on the school website. Well done Year 6. That's the end of another Maths Home Learning lesson. See you tomorrow for our next Maths Home Learning lesson.